All right, ladies and gentlemen, I just wanted to touch on a few concepts that we started yesterday. Maybe didn't get quite all the way through. So I wanted to offer you a little bit of further information to really embed this, make sure that you understand it moving forward as you begin the 10 questions of the types of chemical equations. If you recall from yesterday, we said that synthesis was to build, right, or to put together. That's how we characterize the both of them. And if we look at just a very basic level, okay, you have element A, which we're going to circle here in red, and you have element B, and then we have element B over here and element B over here. And what you've done is you've taken two individual, okay, elements and you've combined them to make one compound. Now, is it possible that this could be a small compound and this could be a small compound and you could create a larger compound? Absolutely. Still very true. Does not necessarily have to be elements, right, on the reactant side. It can be small compounds. The trick is that you are creating a larger, more expansive molecule here on the product side. So when we had decomposition, right, we talked about tearing apart. That's pretty simple because, again, it's really just the opposite of everything that you're doing when it comes to synthesis. Now, when you have this decomposition, okay, you've started with a compound. We're just going to call this element A and element B in compound form, and you're tearing apart the compound, and one of two things is going to happen. You're going to create two smaller elements, or you're going to create two smaller compounds. Again, the key is that you are creating something smaller. You're taking apart what was a compound, more than likely a complex compound, and you're either creating it into smaller compounds or these are going to become elements. And it could be one of each. That's certainly possible as well. Now, with a single replacement, you are now entering into the world of a little bit more difficulty. Remember, anytime you look at a potential chemical reaction, you always ask yourself, is it synthesis first? Is it decomposition second? If it's neither of those two, and it's not very obvious, because again, those are the two most obvious, you are going to then move along into single replacement and double replacement. And remember the root of replacement. Replacement doesn't necessarily mean that I'm getting rid of something. It just means I'm moving one element in and I'm moving another element out. Or I'm moving one compound in and I'm moving one compound out. So in the case of a single replacement, we said yesterday, move one out and move one in. And again, we are referring to what could potentially be. We have a compound here. We could have an element here. And what we've created on the product side is a new or differing compound. And what we have here is a singular element or a smaller compound. Again, the key is that you started with AB on the reactant side and you ended on the product side with AC. Also, another way to look at this is to say that A stayed stationary. It's in the same exact spot on both the product side and the reactant side. I have moved in the C, and I have moved out the B. And anytime you can identify which element has moved into a new compound and which has moved out of a new compound, you have single replacement. So I think at this point, it should be relatively obvious, right, that a double replacement is going to be move 2 out and move 2 in. So when you have movement of two elements or two compounds, you're creating differing compounds in many cases. So let's take a look. I have the elements or compounds that have stayed stationary, again, across the reactant side to the product side are going to be A and letter D. You'll see that they are in the same exact positions, right, on both sides of this chemical formula. Which of the elements or compounds in this particular case have moved? Well, let's start with B. B is combined with A over here on the reactant side. On the product side, it is now combined with D. Also, we have the movement of letter C. Again, it can be an element, it can be a compound, but it is on the reactant side combined right here with letter D. Over here on the product side, it's combined with letter A. And because you have the move in of letter C and also letter B, okay, but you also have the move out of, again, B stays stationary, or excuse me, B is the movement out, and also letter C, right, is the move out. So the only two that have stayed stationary are letter A and letter D. Letter A and letter D are in the same spot. So letters B and C have both moved out and moved in, and therefore it makes it a double replacement. If you have questions throughout the day, feel free to email me. I will be available a majority of the day. Otherwise, try to have a good day, and we'll see you all on Thursday.